Macros are a wonderful new tool provided by Swift as of version 5.9 that can add all new superpowers to your code. And most people here have probably interacted with macros by using the ones provided by Apple, which include the observable macro, as well as Swift Data's model macro. However, there will eventually come a time where you will want to write your own macro, and it can be quite difficult to get right. Because macros are essentially Swift programs that analyze existing Swift code to produce all new Swift code. There's a lot that can go wrong, and you end up with invalid Swift code. So today, we're going to be discussing how one tests macros to ensure that they behave as expected over the many, many, many different ways that they could be used.
Okay. But first, we are Brandon and Steven, and here's some of our contact info. Please feel free to reach out if you have any questions. And then you may know us from our website, Point Free, a weekly series covering some advanced Swift topics, such as what we're going to be discussing today. And so if you find this interesting, you may also find those videos interesting. And also, interestingly, this is our first ever joint presentation at a conference. Of course, been on videos, a lot of videos. And it's been also 2 years since we've even been under the same roof at the same time, because now we work completely remotely and we record remotely. So we're really happy to be here and be together. And so we'll start with the basics of which is just what is a macro. Now, we're not going to go into great detail about this because there are a lot of different flavors of macros and there's a lot of different ways of using them and implementing them. So we're going to assume you know the basics, that you're kind of roughly familiar with what went down in the WWDC sessions from last year. And so in this talk, we will mostly concentrate on the testing, but we will just say at a very high level, macros are compiler plugins, and in fact, they're little executables on their own, and they're invoked as Swift is compiling your application's code. And they're declared in an SPM package, and they even have their own little kind of macro target. Macros can be applied in one of two ways. They can be attached directly to existing code, and that's when you use the little @ symbol, and that indicates that this is a macro. And probably the most popular one, the most used one right now, is the observable macro that's applied to this class right here. And it enhances this class with all new extra capabilities that allow it to be observed from the outside, observe what happens inside. And then there's also freestanding macros, and that's when you see the little hash sign or pound sign. And so this indicates that this is a macro that doesn't need to be attached to existing code. It just kind of stands on its own. But what can macros do? Well, first and foremost, a macro just simply inserts more Swift code into your application that then gets compiled alongside all your other code. But macros can also, so that's generate Swift code. But also macros can generate diagnostics like errors and warnings, and those are shown right in the Xcode editor. And it can generate fix-its, which give you a nice little UI in Xcode that allow you to apply the fix-it, and it rewrites code that's in the editor to make it more correct. So if you detect a problem, you can fix it. And then finally, the process of running a macro can then apply more macros, and this process that I'm describing just continues and continues. Now, it can't continue infinitely, it can't do it recursively, but it does allow it to go a few more times. So let's look at a couple of examples of macros, starting with the few that Apple ships right now, which is the observable macro. And this is even a part of the open source Swift project. You can actually look at the actual source code in GitHub and see how this is implemented. And it's a lot of code. You don't have to know what this code is, but if we took that observable feature model that I showed a few slides ago, it expands to all of this. And so in essence, what it's doing, it took that stored property. I only had one little stored property on the class, and it turned it into a computed property and another stored property that was then underscored. So we had this underscore count. It also adds some methods like access and with mutation, and it adds an extension to the observable protocol. And this is the code that we wrote a moment ago, and all the other code is what the macro inserted for us. All right, so we, of course, would never want to write all that faded out code ourselves. And then there's also the model macro, which generates even more code. And so we are getting all of this code here for free from having just written this little bit of code right here. All right, so it's a pretty remarkable thing, how much code can just be hidden from you. And I don't think any of us would really care about these details here. And so this code here is what gives the Swift data all of its superpowers. All right, and then we've got our own macros that we've built in some of our libraries. Like we have a library called case paths, and its whole purpose is to give enums a key path syntax so that you can use key paths on the cases of enums. And the way we do this is with this case pathable macro. And it allows all types of interesting things, but none of that matters. All that we care for the purpose of this talk is that it generates all of this code. So we get this code for free from the macro, having only written this code. And then also it generates diagnostics. We do not allow you to apply this macro to struct, so we detect that. We present a nice little message for you. Then we've also got a little dependency library out there, and it's got a little macro that allows you to write really nice, lightweight dependency interfaces and generate a whole bunch of stuff that you don't have to care about. But we don't really care about what this dependency client macro does. What we care about is that this is all the code it generates, in particular this code, when this is all you wrote yourself. All right? And it also has a fix-it. If you have a little dependency client and you do not annotate one of the endpoints, one of the closures with some type information, we say, hey, we need this information, hit fix it, and then boom, this little placeholder is inserted to really guide you, to let you know what it is you got to do to fix it.
So Brandon just showed that macros can generate a lot of code for you, and it's really great because we can concentrate on the core domain of our code without having to worry about all of this boilerplate to maintain. But the downside is that the more code that we generate with a macro, the more things can go wrong. And it's very, very easy for something to go wrong when implementing a macro. For example, the observable macro needs to be careful to only transform stored properties of the class and leave computed properties alone. If it tries to expand additional code for the is-even computed property, it will generate invalid Swift code. And likewise, extra care has to be taken with let variables versus var. If it were to expand the let with get or set accessors, that would also be invalid Swift. And access control can also be very tricky. For example, the model macro not only extends a class to a protocol, but it actually implements some of the requirements of the protocol. And it needs to take care to take whatever access control is applied to the class and also apply it to those requirements. Because a public class conforming to a public protocol must define its requirements in a public way. Otherwise, it again will generate invalid Swift. And more generally, one should always be mindful of how access control of the code a macro is attached to could affect the access control of the code that it generates. And there are also situations in which a macro cannot possibly generate valid code for the code that it's attached to. For example, it's technically possible to overload an enum with cases that have the same name. However, overloaded case names aren't very useful in Swift due to a Swift bug that prevents you from actually switching over them. But further, if we were to naively have the macro expand all of these overloaded cases, it would produce invalid Swift because properties cannot be overloaded. And so we need to do a little extra work by analyzing the code and emitting an error up front so that we don't generate invalid code. And then another thorny situation is when compiler directives are involved. There's a very popular case study for macros, which is the memberwise initializer, and it generates a public initializer for all the fields of a struct. But if some of those fields are hidden behind compiler directives, like this if debug, then you need to take extra care in generating an initializer that works across all of these conditions. And that can be very easy to get wrong. And this is actually something that came up in our case paths library. There were people using our library that needed to use case pathable with enums that have compiler directives. And so we needed our macro to support all of these different compiler directives and ensure that we only generate these properties within the same kind of structure. And the structure can get very complicated. You can have multiple conditions in a directive. You can have them nested. You can have else if and else branches.
And this is only a small taste of all the complexities that one has to think about when writing a macro, because Swift syntax, for as much as we love it, it can be quirky, to put it nicely, and that puts a lot of responsibility on our shoulders to make sure we deal with all this quirkiness in the right way. And we are going to show off what is the tool that Apple gives us for testing macros, because honestly, I think we're kind of lucky that Apple even provided this tool, because many times it feels like Apple releases SDKs and libraries that are not really built with testing in mind, and it can be difficult for us as developers to write tests that verify things work the way we expect in an automated way. And so the tool they provided to us is this little function here called assert macro expansion. It takes 3 arguments. A string, which represents the source code that is using macros in it. The second argument is another string, but the source code that you expect once all the macros have been expanded and all that code has been inserted. And the third argument is just the list of the macros that you're using in the first string. And so when the test runs, the assert macro expansion function expands all those macros in the first string, and it gets a whole new string, and it compares that with the second string. And if those 2 strings don't equal each other, a test failure is emitted, and it will even show a nice diff message of exactly what went wrong. And let's live demo that right now. So we'll switch over to Xcode. All right. And what we can do, right now I'm in our case path library, and I'm going to write a macro test for our case pathable macro. And you do assert macro expansion, as this one right here, and then you can provide a little bit of Swift code right in a string, and you say, all right, case pathable enum, we'll call it event, and we'll say we have a case load, and you provide a user. All right, and already this is kind of tough. I would have to be able to recreate everything that the macro is going to expand and write it all here from memory. I don't think that's really practical. I don't think that's how anyone actually tests macros. So instead, I'll leave it as an empty string and get a test failure. But I will say that case pathable should expand using our case pathable macro. All right, and so I just run the test. Anyone see the failure? Oh. Okay. Xcode. Xcode being Xcode. All right, so I got a failure, and it tells us that, of course, yeah, you didn't assert on anything, really, and it tells us all the code that we missed on asserting, and it even gives you a little helpful of the just the raw case path code or the raw macro code that's expanded. But also, interestingly, due to how Xcode works, I can't even get to the bottom of this. And so for the purpose of this, I'm going to just hold Shift, press down a bunch, hope I get it all, copy it, go over here, go to my expanded source, paste it in, and hopefully that passes. But it doesn't, and that's because technically my indentation is a little bit off right now. I mean, it looks like all this stuff kind of roughly matches up, the plus and minuses, but all this stuff is indented a little bit more. So what I could do is I could undo that, and maybe I do Command Option Shift V. Now it pasted preserving formatting, but the first line is wrong because my cursor was there. So actually, all right, let's undo that. Let's go back to the beginning, paste preserve formatting, then go back and re-indent, and now let's run. Okay, now it succeeds. All right. And then you would look at this output and be like, all right, this seems reasonable to me. This is what I think my macro was supposed to output. But then if I change things slightly, like say I add a user argument label, because maybe this is something I'm not handling correctly, I get a failure, of course, because yeah, it changed. That's completely reasonable. And it's really nice that it provides this little difference here for me. But it now is my responsibility to go in and either fix it or go through the whole copy-paste thing again. But this one was easy, so I'll stick with this. But then diagnostics are a little strange because I'm going to go in here, I'm going to get test coverage on that load user ID with a user ID. And so here I'm using an overloaded case name that should not expand, and instead it should do a diagnostic. Oh, it's running. All right, so we get two failures. One is talking about diagnostics, and that's good. We didn't assert on any diagnostics here, but one was generated. But then it's also complaining that this is no longer valid, and that's because, yeah, it should not be expanding this macro when there's a problem. So I guess I could manually do this, or I could have done the copy and paste again, but I'll manually do it. And that will take care of the one test failure, but the diagnostics one, now what I gotta do is I gotta manually assert on this by providing diagnostics, this diagnostics array, creating this, specifying the message line and column, and I'll cheat by seeing that it's on line 4, column 8, and this is the message. So I grab all that. So I got message, I got message 4, 8, comma. Let's run this. Oh, and I got a space here. Okay. So it was close, but now, okay, what else? Oh, and all right. I honestly am not meaning for it to seem this difficult, but we're getting that for free. So all right, so yeah, this is what's happening, and it's nice that the tool is here, but clearly the ergonomics are not quite there. We're doing copying and pasting. We have a diagnostic that's described in a very abstract way rather than literally seeing where it's applied in the source code. So we would hope that we could do better.
And this is what motivated us to create our own macro testing library. It's called Swift Macro Testing, and surprisingly, it's actually built on the backbone of our popular snapshot testing library. If you didn't already know, we have a snapshot testing library that allows you to snapshot any kind of data type into any kind of format, not just views into images, but you can snapshot text into strings as well, any kind of data type into any kind of format. It's even able to inline snapshot data as strings directly into your test file, and we call that inline snapshot testing. So let's demo how our snapshot testing helper, or our assert macro helper, compares with Apple's so that we can compare the differences. All right, so
Do you want side mirror now?
Actually, yeah. All right, I'm in the same test file that Brandon was in earlier, and I'm going to import our macro testing library right here. And then I'm going to do a little bit of setup work. You don't have to do this. But in a single place, we can use invoke test, and that will do some of the upfront work of setting up the data that was passed along when Brandon wrote his test. And now I will write a very similar test that he started with, except I'm going to be using assert macro. Here it is. It only takes a single argument, which is a trailing closure that has a string. And this is the same string that we were testing with assert macro expansion. I'll get the basic structure in place, but I want to go back to the original just to see how our tool compares. So it failed, but if you observed, it also expanded the code in place. I didn't have to copy and paste it, manually type it out. It just recorded into place. The failure is that the recording happened at all. And to verify that the code is correct, I can give it a once over, run the test again, and it passes. So that's great, but what happens when we make changes to our code? Well, I can go in, I can add the label of user, I can run the test again, and then we get a failure down here with the expansion, and similarly to Apple's tool, we get to show a nicely formatted diff to show us what went wrong. And it makes sense to me, but instead of typing it manually like Brandon did, we have the ability to add another argument called record. And this lets assert macro know that we have a new version of the macro and we want to record a new expansion for it. Okay, and so it did the work for me. That's great, but things get even better when it comes to diagnostics. If I'm to add in an overloaded case here that takes a user ID, and I'll keep it in record mode because I know what I want to test. I can verify it after. When I run it, it's subtle, but it actually swapped out the expansion because there was a failure, and the expansion isn't something that we really care about. And instead, we have this diagnostics, where we're not describing in the abstract of line 8, column 4, or was it column 4, line 8?
Yeah.
Instead, we render it right in line. We show the error and even the range of the error. And so that's the basics of how to test a macro using our assert macro helper. And it's pretty great, but we only really scratched the surface here. If you are writing macros or decide to write macros, we really recommend that you check it out. If you have any feedback, let us know. But there is a second flavor of macro tests that we also want to briefly mention. So far, the assert macro expansion tool from Apple and our assert macro tool allow us to visually see that the expanded macro code is roughly correct as far as we can tell. But still, the compiler isn't actually trying to compile that expanded code. And so technically, there could still be errors in it. And so that's why we like to have a suite of what we call static integration macro tests, where we simply have a file in the test suite that applies the macro to some actual code, and then the mere fact that the test suite can compile proves that at least the macro is expanding valid code. And of course, the code could be completely wrong, but at least it compiles. And so we feel that these two types of macro tests give us good coverage, that the macro not only generates valid compiling Swift code, but that it is also generating the correct code that we expect.
Yeah. All right, and so yeah, this enum event here, this is a really good example of just us trying to exercise all the weird things that one can do with an enum, like cases with the underscored external name and an actual internal name, and then also defaults and available and all that stuff. And so we want to just wrap up this talk now with just sharing some of the lessons that we've learned, often the hard way, by having written many, many macros. And we've written a lot of macros so far, and we've gone through a lot while working on these. And each one had its own unique challenges, so we'd like to kind of steer you in the right direction as you start writing your own macros. And our first lesson that we want to impart is that it is far, far better for your macro to emit a diagnostic than to rely on Xcode to emit it for you. So what this means is if your macro generates code that has an error or a warning in it, Xcode typically, and almost all the time, will not actually display those errors and warnings directly in the editor where you would hope. Instead, you got to go to the issue navigator in Xcode and look in that little sidebar and find the issue there, but there's no correlation between that issue and your actual user's code. And that's a pretty bad experience for the users of your macro. So we recommend you do all the upfront work in your macro, find the problems, emit the diagnostics yourself from your macro rather than relying on Xcode. However, there is a caveat, which is when your macro applies other macros and that little child macro decides to emit a diagnostic, you will just run into a compiler crash. It's extremely unfortunate. We filed issues for it, so hopefully it'll be fixed sometime soon. But what that means is that if you truly want to provide the absolute best experience for the users of your macro, It means you have to go the extra mile and have the parent macro find all the problems that the child macro may find and have it emit all those problems rather than, or emit those diagnostics rather than let the child macro emit those errors. It's a huge bummer, but it really makes a big difference for the users of your macro.
The next lesson that we'd like you to consider is to just write lots and lots and lots of tests. Hopefully, thanks to our Swift macro testing library, it becomes very easy to do so. And so we just recommend writing many for every single little edge case and Swift quirk that you can think of to ensure that your macro works over all of the code that you might attach it to.
And then also just exercise many Swift features. So make sure you're writing tests and getting coverage on things like access control, things like the availability attribute being applied to properties or enum cases and types. Compiler directives can get really tricky. Overloaded case names is often something you have to think about. Closures with named arguments are kind of interesting because they're not allowed to have public-facing external argument names, but they can have internal names. And so if you're doing anything with Swift syntax and macros to deal with that, there's a very good chance you could get it wrong. So you should write some tests on that, and there's just a lot. All the fun, quote-unquote, fun quirks of Swift you want to get some coverage on.
And finally, when you come across a bug in macros, and you almost certainly will right now, file a bug with Apple. Since most macro bugs are in the Swift compiler, you can even file them just using GitHub issues in a public fashion. You only really need to file a feedback if the bug involves Xcode. And also, to increase the chances that someone actually takes a look at your bug, please provide just the most minimal, complete repro that you can. This makes it very easy for someone at Apple to reproduce the problem and figure out how to triage it.
Okay, and that is all we have today. We hope you all write some macro tests, and until next time.
Until next time.